Good morning, everybody. Welcome to our August webinar. We're very excited with our guest we've got today. We've got Nelson, who is with Corteva. He's a senior nutritionist, and we're going to talk about silage. It's obviously one of those that in the next little bit is going to get started, maybe fairly early for some that are looking at pretty poor crops in certain parts of the province. And that's really what we want to try to tackle today. As we know, there's a lot of variability across central and eastern Canada. And we want to really give you kind of the best information we can for managing that. So there are parts that are looking at pretty decent crops. There are obviously parts that are looking at pretty poor crops because of the dry conditions. So we want to be able to basically answer all those questions and have Nelson kind of roll through his slide deck, going through some of those things that, some of them will be review for you, and some of them I know are going to be, new pieces of information that will help. And absolutely, this is the time to, if you do have questions you want to ask Nelson, he's happy to answer throughout the next hour or two. So what you need to do is across the top, you can see the chat box. Or the Q&A box. Either of those you can drop questions into. I'll keep an eye on those, and we'll kind of flag Nelson as he goes through his presentation. So don't forget the chat box and the Q&A box. But Nelson, it's great to have you. You are the senior nutritionist. You're out of Iowa, right? I forgot to ask you that. You're based in Iowa. It's great to have you. I will give the floor to you.
Perfect. Yeah, as you said, I'm based here in Johnston, Iowa. As you can hear, I have an accent. I'm not from Iowa. I'm from Chile originally, so my native language is Spanish. And even though I've been in the States for more than, let me think here, almost 20 years, right? This is as good as it gets. My accent is not improving anything, so for no means, like if you need me to repeat anything, I won't feel offended. So you can stop me and say, hey, you know what, can you repeat that stuff because I couldn't understand. So, all right, so welcome, and we're going to talk about harvest, bunker, and storage management today. All right, let me see. Here is my laser pointer. Here is my next slide. So in this slide, this is like to set up the stage a little bit. We can see here that this is an analysis of cost of milk production here in the States. Pretty sure that in Canada must be a similar situation. It compares, the range of times from 2016 to 2021, okay? And you can see here that the cost of producing milk that is shown here by red in 2016 was 45% of the total cost of milk production. Now, if we move forward to 2021, that cost increased to 52%. So feeding is very important for your economic success in a dairy farm, okay? All right, so here is the obvious, and then producing the high quality forage as high as possible is key, okay, for your operation. What it does for you, improves the return on assets, right? You have a limited amount of land, you have your equipment, and by using it too thoroughly, you are improving the return on those assets, right? At the same time, the more feed that you produce on your own farm is going to reduce your reliance on purchased feeds. Like if you have a high quality forage with a lot of starch, you probably want to have to buy or import into your operation less corn grain, right? And the basic principles for good silage are simple. It starts with harvest timing, right? Also, when you are making and putting up your pile or bunker, the rapid removal of air, you want to, become anaerobic as soon as possible. The other thing is that you need to have is a rapid production of lactic acid. So the mass, the pH of your silage mass drops quickly, and then you have, stop the growth of spoilage microorganisms. And the exclusion of air must be continual during the whole process of ensiling, from the moment you seal the pile or bunker, you want it to remain intact. The plastic has to be intact. You don't want tears or holes or animals, ripping your plastic. Okay. And the thing is that all those factors are basically under your control, okay? So now, how do you control harvest timing? You have to keep an eye, and probably this is not news for many of you. Um, Milk line. Milk line is super important. You have to keep an eye on milk line. Here you see, quarter milk line, half milk line, 3/4, which is a current recommendation. And here is a zero milk line or black layer. This is a moment that the plant or the grain, stops pushing starch into the grain. And that's how you call it, the physiological maturity of the corn, right? We have here that some companies have recommended harvesting at around 1/3 of midline. And the reason for this is that they have problems with late season health on the plants, right? And the idea is they are trying to push a little higher NDF, right? The only problem is that that's going to cost you a little bit of yield and starch, right? Okay, so healthy plants, this is very important to stress. They can remain on the ground, for longer. It can be harvested closer to 3/4 midline, and that way you're gonna maximize the starch that you're gonna capture from the field. It is a chart. It's a little bit of a busy chart, but it's an important one. What you can see here in the x-axis is the silage dry matter at the moment of harvest, right? Traditionally, we have been shooting for between 30 and 32% dry matter for going harvesting. Today, we are trying to encourage people to wait a little longer and try to harvest around 36 to 38% dry matter. The reason for this is that you can see here in the green line that the loss is NDF, the loss in NDF digestibility is not that much. You go down from 47 to 44%. So it's a minimal loss in NDF digestibility. However, if you look at the starch, you can have a significant increase on that. And starch is the energy that you need for milk production, right? It has been estimated that the starch can increase as much as 1% per day that you leave the plants. They are healthy, photosynthesizing in the field. Okay. And one thing that is important to remember that the fiber digestibility is determined at the moment of your harvest. Everything freezes there. Your fiber digestibility is not going to change during the silent process. What is going to change though is the starch digestibility, because the longer the longer it remains in that acid environment, the proteins in general that surround the starch granules, they start to degrade, and that releases them later when the cow ingests them, right? So here is what I was just saying.
Can I pause you for 1 second, Nelson, because we do have one question, and it kind of relates to both this, the moisture as well as the milk line. And the question comes in from Eric: is that how much does milk line affect the moisture of the silage? Do they go hand in hand? That third milk line is going to be kind of wetter no matter what, or what's the relationship between moisture and milk line?
Yeah, the relationship, there is a relationship between grain and whole plant moisture, right? When you have plants that are barren with no grain, usually they are more wet than you may expect, because it's the grain in the cob that drives that dry down, right? The movement of water out of it. Now, the question related, yeah, I mean, as the milk line advances, the dry matter in the plant increases, right? So they do go hand in hand, but there is a factor there that is the health plant, right? How healthy the plant is. So when you are, for the moment of harvest, you can rely in healthy plants to the milk line. But when you have situations, you want to have a double check and have a couple plants cut, chip them, shred them, and do actual dry matter. Okay. So yeah, there is a relationship, but it's also affected by environment and the health of the plant. I hope that helps. All right, so that was what I was trying to say, that rather than target, between 30 and 32, we are trying to push people to keep healthy plants on the field longer so you can harvest more NDF harvest more starch without affecting too much the NDF. Okay, here is around healthy plants. Healthy plants maintain better fiber digestibility. In general, they will yield more starch because they will remain in the field, photosynthesizing. You will have more fiber, more tons, and usually they have a more wider and flexible harvest window. Now, how do you manage this plant health? First, you will be like hybrid genetics, like choosing the right hybrid for your field. The other thing that you can consider is application of fungicides and also, the nutrient availability and uptake of that plant. Now, there is a couple rules of thumb. As a healthy plant matures in the field, each 1% of dry matter that plant accumulates usually can translate up to 5 bushels extra per acre of grain. That 1% also represents a 0.6% of starch. In general, that 1% also can give you, is around 0.3 tons per acre extra, right? And the decline in DF is around 0.2%, right? So if you take an example, if you were to leave that plant that is healthy to mature from 32% dry matter to 37, so you're giving it like 5 points of dry matter extra. If you use a rule of thumb, you're getting 25 bushels per acre extra in grain, a 3% of starch, 1.5 extra ton of forage, and the loss in NDF is not more than 1%. And the important thing is that the red thing that we're saying here, and this is all with no additional input, right? You already pay for your seed, you already, the fertilizer is there. So, that's the value of holding and keeping an eye on your plants and how are they drying down. Here is an example. This is data that was collected in a trial that was conducted in Michigan, 21 and 22. And you can see that it wants to show the impact of fungicide application on silage yield and the quality. But I'm going to show you just like the yield part only because it's just too much stuff. So you can see here a situation, in this field, there is low disease pressure. You see the image, a satellite image, you see very uniform color in the image, right? And now here's a situation with high disease pressure, right? And then here is where how the field look like actually, so you can see the color, the plants look pretty healthy. In this case, you have like decoloration, and here is a bright green, right, for the fungicide applied. Now, what were the results in terms of yield? The application of the fungicide dependent on the disease pressure, right? Clearly, in a situation where you have low disease pressure, there was not a lot of difference in terms of tonnage per acre that were harvested, 29 to 27.9, right? Now, in the situation when you have a high disease pressure, we were talking about like almost 4 tons difference of silage. Okay, so the response to a fungicide application will be determined by the disease pressure, right? So under a high disease pressure, they observe, more yield, more starch, and better NDF. Under low disease pressure, it was a marginal increase in yield and starch. However, in both scenarios, you got the plants to remain green for longer. So that gave you a more forgiving harvest window. Now, I know that there are some areas in Canada that are under condition of drought. So that's why I'm going to talk a little bit about drought, how to manage drought corn. Here is an image of, stress corn. I couldn't find. I have one image of drought corn a little farther, but this is just, stress corn. All right. The general recommendations to manage drought corn is that don't high chop drought corn, right? The problem that you have here is that you are tight in inventory, and so you don't want to reduce your yields anymore than you have right now. Okay, And in general, the yield is going to be variable, and it's going to depend of the success of the pollination during that and the starch field. Like depending on when the drought hit you, that's going to determine what the forage yield is going to be expected. The rule of thumb here is that corn that doesn't have an ear, it's you're going to get about 1 ton per acre per each foot of plant height. That gives you like a ballpark of how much you expect. Now, height chopping, we know that that's a practice that allows you to increase your NDF. However, that's only the recommendation is like when you have above average moisture, like because you're going to sacrifice a lot of yield. That's when sometimes it's worth to consider height chopping, right? Now, it's typically not recommended when you're talking about like a dry, when the dry season hit the plant when it was in the vegetative stage, because generally, if you're chasing NDF, plants that were stressed or like limited in water during the vegetative stage usually have good NDF, the digestibility is high, okay? And then you don't want to shoot yourself in the foot, if you already have shorter plants and you're gonna, cut your inventory. And the typical reduction in yield when you are doing like a height chopping, every 4 inches that you raise the cutting bar, you're probably gonna lose about half a ton per acre. However, you're gonna increase your starch, and typically you can see a 7% starch increase and fire digestibility about a 6% increase too.
Maybe we can just pause for just a second. A question just came in, Nelson, from Chad, and his concern kind of goes back to dry matter and moisture is in the reality that the cob, really hasn't developed the way that it needs to properly. It's there, but it's not. It's there's still a lot of moisture there. The plants though are browning, drying, getting to be, fairly brittle. What's the best, you wait for that cob to develop and get a milk line, but you're losing, some of the moisture that's going to help you pack that from the plant. What's the best strategy really to pick what the best moisture is to get both kind of, to balance that quality and the moisture?
Yeah, this is the issue you have here. Droughted silage is going to look a lot wetter. It's going to be a lot wetter than you expect. And this is because of the lack of grain in the cob. Because I was saying before, like the grain in the cob drives that dry down, right? It's the one that, takes the water out of the plant. So here is something that may help to answer that question, because, these are plant examples of a big drought that we had here in the States in 2012. You can see here, these plants were not only droughted, they also were hit by hail, right? So you look at them and they look pretty sad. I mean, you look at that, they look like, broomsticks, all barren and, dry out. These ones are, look a little better because there is some green on them. But when you cut the plants, you will be surprised that the difference in dry matter was like 4 points, right? So you cannot rely on the way they look. You have to cut them. You have to cut them and dry them and to figure out the actual dry matter, because your eye is gonna fool you. Okay. The stems look dry, the stems look brown, but they contain a lot of water. And the reason for that is that, when you don't have like the cob pulling that and depositing the starch, all the sugars remain in the stalk. And they are they are like also diluted in the sap of the plant. So okay, I hope that helps. So I mean, that's a recommendation. Cut them. They're gonna don't rely on your eye. The aspect is gonna fool you. All right. So usually the other reason why you may want to height chop is because you have concerns about like nitrates, right? And usually, if you have droughted plants, we don't recommend that you height chop them. Generally, what's going to happen that the ensiling process is going to take care of at least half of the nitrate problems. If you really have like concerns, the best thing will be like submit a sample for analysis. But if your analysis come back, in this range from 35, 4,000 ppm, you know that the silage process is going to take care of at least half, and it's going to bring you up to safe to feed range, which is here. Okay. So yeah, if you are concerned about nitrates, do an analysis, but don't high chop for that reason only. And this is what, yes, I showed you before. The routed silage is going to be a lot wetter than it looks like, and this is because of the lack of grain in the cob. Now, from the nutritional point of view, the corn, even though it doesn't have an ear, right, is going to give you about 60 or 70% of normal corn silage, right? And the main problem is going to be a lack of yield. These plants are, in general, going to be highly digestible, but they are, you're not going to have the inventory you need. So in general, it's going to feed like a highly digestible grass silage, right? Because of it's not going to have the grain there, but it's going to be highly digestible. Now, the stress, the drought stress is going to increase the fiber digestibility. So the NDF should not be a concern there, right? So that's why you don't want to high chop if you're chasing NDF digestibility. There is no need for that. Now, if you have corn with some ear development, it will be, the starch level is going to be lower. But you're going to have that starch that didn't, that sugar that did not convert, it still remains in the stem. So your plant, when you analyze, is going to be high in sugar and high in protein. So, but how much is going to be hard to estimate. So that's why you probably want to allow analysis to figure it out. The issue with that sugar that is not converted into starch is going to be in the stalks and leaves by the moment that you harvest. And that is going to be fuel for a lot of microorganisms. So you can anticipate that dinner is going to be served for microorganisms. So you're probably going to have issues with, poor fermentation and aerobic stability in the bulk, right? So you have to be prepared for that situation. Now, the other thing that you want to do is like keep an eye on the plants, the general health of the plant. Don't let them go too far, right? If you delay, you may suffer from lower digestibility, right? If you have plants that are visually, obviously, diseased, try not to delay harvesting. All right. Here is another thing that, keeping the same line, right? Drought corn silage is high in sugar and is loaded with yeast. And that's going to increase your dry matter loss, and it's probably going to initiate heating both in the pile and the feed bank. It's going to be more susceptible to heating because of that. There is plenty of food, The sugar is soluble more than starch. So it's, as I said before, dinner is served for all these microorganisms. Now, here is another example of that drought of 2012. It was serious. Like 37% of continental U.S. was listed as severe in extreme drought conditions. Right in the Midwest, 10 out of 12 states experienced their top 5 warmest July on record, and there was an estimation of 32 billion in crop losses that year, right? So the point of this slide is to show you that stress corn is going to be even more loaded with yeast. Here is an example of samples submitted to Dairyland Labs in 2012, and you can see that most, 50% of the samples submitted, 50% of the 183 samples in this chart had, yeast counts in the range of high, right, which is above 1 million CFU, right, in this range here. So stress corn will have more yeast load. It's going to be more susceptible to. Now, what are the implications? The more yeast, the x-axis here is inversely related to the aerobic stability. More yeast in your silage mass, your aerobic stability is going to decline, right? This is a clear relationship there. But now, what are the risk factors for poor aerobic stability? As I said here, high initial discounts. If you're starting with high discounts, you're going to be, probably a candidate for problems with aerobic stability and heating. And the other thing is that if you don't remove the air in the pile, you're just keeping those yeast alive and just waiting for the moment to jump on your neck. Here's an example of, silage, haylage actually, heating up. And here is what happens in the pile if you look at them with a thermal camera. You see the combination of, lack of packing, which usually happens here around the walls, and also along the top of the surface where the plastic touches the mass, right? That's where it's exposed to air, and that's where you have like the most heat develop in the pile. Now, how do you stop yeast? The recommendation is to use an oxygen barrier film in addition to your plastic, typical plastic. And, it starts with making the pile, right? Good compaction, keeping an eye on the moisture, and also, using the oxygen barrier film and using probably a crop-specific Buchneri inoculant. Now, a word in innoculants. Here you can see with here in Pioneer we have like a system of 3 products. Basically this is the simplest, cheapest product. The 1174, and as you move to the right, you get like the good, better, and best. Right. That's basically the philosophy. Now you have 1174, which is a basic homofermentative. It's like kind of a price defensive insurance type product. And usually you will recommend this stuff if you are not going to feed silage during warm times of the year. If that silage you're going to feed it, winter time, you have less risk. So there is no need for a product like this one that is going to help you to reduce yeast, right? Because the rapid react, the Buchneri strain, what it does, it produces, in addition to lactic acid, produces acetic acid. And acetic acid inhibits growth of the yeast, right? And it's going to help you once you open it to prevent that heating in the pile and in the bunk. Now, Elance CFT, that's a product that helps you, with the digestibility of the fiber. And usually we do not recommend it in situations where you have experienced drought, because usually your fiber digestibility is not going to be an issue in those situations. So you probably don't need that one. It will be an overkill. Now, there is a strategy that you use, to kind of price average products and, silage inoculants by switching as you feel, right? So you kind of time, and how many cows you have. So you put so many tons, estimate your intake, your needs, during winter time, right? Here, and then you use a cheap inoculant, and the ones and the the tonnage, or by the time you reach summertime, warmer temperatures, you time that, and then you use an inlet C33, which is a little more expensive. All right.
Maybe I'll pause you for another second here, Nelson. We got a couple of questions. One goes back to your slide on nitrates, and it's that if high nitrates are suspected, how long after harvest would you need to wait to feed to be safe?
Yeah, that's an excellent question. I will say it will be hard to set a day like so many. Usually a fermentation, within 3 to 4 weeks, you will have like a silage mass that is stable. So I would expect that by that time, the nitrates should go down to safe. But this is a speculation. I cannot cite you like a paper or formal research that I can back my I can look into that stuff if you give me the, because I think it's important.
Yeah, so nothing necessarily specific, but definitely you need that few weeks anyway.
Yeah, for sure you need to let the process go, and and the fermentation to become stable, right? That will assure you that you have dealt with the nitrate situation.
Uh,
That's why I'm estimating, between 3 and 4 weeks, because that's when usually the pH, if you use a rapid react, for sure, within a week, you're going to have like a stable mass. But if you're not using an inoculant, probably that process is going to take a little longer. So that's why I'm saying between 3 and 4 weeks.
Another question, you were talking about, you had that slide that had the droughted corn,
Yep.
and there was a 4% spread in moisture. Is that 4% spread as big of a deal in drought stressed corn as it was in, kind of the more average corn when you talked about, starch and things like that? How significant, I guess, is the question, is that 4% spread in dry matter in drought stressed corn?
And in droughts, I mean, the reason why we want to wait when you have, if I understand the question, like, okay, so if you have normal corn, that 3 or 4% is going to be significant, because it's going to be like, the plants are healthy, the plants are photosynthesized, and so you are accumulating starch, and starch is energy, energy is money, because you have more milk. So those 4% are for sure important in those terms. The reason why the 4% spread in drought corn, um, maybe, you're not accumulating starch anymore, so it's more like a matter of stability. Because the problem that you have is that if you go in and ensile that corn that is higher in moisture, your 4 points of moisture, right, you may be having problems with seepage, right? You're going to start packing, and you're going to start seeing that the runoff. And the problem with the runoff is that those are all the woodies, those are all the soluble sugars that you're going to be losing. So all those sugars that didn't become starch in a healthy plant, you're gonna be like, because of the high moisture, you're gonna be squeezing them out of the silage, right? So that's the reason why, yeah, you don't want to go into a pile with that such high moisture. And the other problem that you have, if you have high moisture, going into your silage pile, think about it. That water is going to dilute your acids, right? So reaching the low pH that you want to have it, stable, it's going to take you longer, because that water is going to have like buffer capacity, right?
So then one of the other questions that's popped in here too is on that preliminary chop sample. We're going to take it, we're going to put it through a, chopper of some kind, and get kind of the assessment of what dry matter is in order to be able to, kind of properly predict when we're actually going to go chop. Should you be sending a sample to a lab for analysis at that time too, to assess your sugar and yeast, to kind of know what you're also getting into in that, sense, Nelson?
It, the more data you have, you're better prepared for what's coming, right? Now, that data that you acquire, you must be ready to take action on it, right? So yeah, sure. I mean, if you have a fast turnaround, you can send a sample to a lab. But usually, that the problem is that sometimes you are kind of stressed on time, right? Sometimes the timing, you are better focus on dry matter, maybe, perhaps, and using a microwave, a coaster cooker, or something simpler that gives you the information you need at that point, rather than, maybe waiting for a week to figure out, okay, I have no problems with yeast, or I do have a problem with yeast. You know what I mean? So every situation is like different. Of course, the more data you have, it helps you taking better decisions. I'm all for it.
Another one, and it's more of a comment, but maybe you can kind of comment on this, on the impacts of kind of weather through that chopping season is one of the comments came in and said they tested a field on Monday before kind of all those showers we had talked about rolled through, and it was 68% moisture on Monday. The same field then tested after they got an inch of rain. They tested again on Wednesday, and it jumped to 74% moisture. So that's a big change with an inch of rain. Is that what you can kind of expect going into the next few weeks? Is that rainfalls can have a big impact on drought-stressed corn specifically?
Yeah, I mean, but the other thing that, I mean, absolutely, but that tells me that those plants were still green. If you don't have green, surface, that it doesn't matter how much it rains on it, right? The plant's it's not functioning anymore, right? So the effect's gonna have the effect rains are gonna have depend on the state of your corn, how live still. But sure, yeah.
I'll let you keep rolling with your subject on storage, Nelson.
All right. So silage storage, right? So here we have a couple images of, those are in the towards the, what is that? That's California, big iron. So the recommendation that we have is that, try to monitor as the trucks are coming into a path, try to monitor your kernel processing, right? And we have a simple cup that is nothing but, a 1 liter cup that helps you to figure out if the chopper is doing a good job, if the chopper is going too fast, or if the chopper needs, to adjust the rollers, right? The idea is that, every so often, every 5 loads or so, have someone who's doing the kernel processing scoring, right? And you're looking for finding no more than 4 kernels, full kernels in that volume of silage, right? Here is an example of excellent processing. You see, just 3 or 4 kernels that are full in that volume. And here is an example of poor processing. Now you see, chunks of cob and a bunch of kernels that are intact, right? So that means that, there are some adjustments that are called for, right? Now, this is an example of a measure that you can do later, when you're feeding, which is fecal score, and you're looking for, being under 3% of starch in the feces. So that's a good indicator of that your processing is being done appropriately. The other thing is that, before you start harvesting, check for wear in your roller mill, right? The other thing, check the gap. It's generally set between 1 and 3 millimeters. The standard chop length is around 19 millimeters, 3/4 of an inch. However, this is gonna depend on what your nutritionist asks you for. If you have a need for scratch, or PE NDF, which is the physical effective NDF, that's gonna modify, or you have to give your nutritionist what he needs, right? So when you don't have a need for PE NDF, probably you can get shorter, and that's going to help you pack and also improve digestibility. Now, in situations that you have droughted corn, maybe you want to chop a little longer, right? And because that may help you prevent excessive seepage, right? The other thing that you want to check is the roller mill, the differential. Historically, it was a 20-30% difference in the speed of spinning, right? Currently, the machines today, they have around 40 to 50%. So that helps you a lot with damaging the kernels. And the other thing is that don't forget to use a processing cap, to monitor the kernel processing quality during the harvest. Okay, so here's what we see.
I'm going to back you up one more time, because we did have another question come in. And maybe what you could do is you could actually back up your slides to the one you talked about, inoculants. We've got a question come in about inoculants. and you kind of had the 3 there. Yep, right there. And this was the question came in that says, if drought causes high yeast content, is the second product a good choice or not, considering it says it will control yeast, but to feed in spring, summer, fall? If they're feeding in the winter, is it still okay to use that?
It's okay. It's still okay to use it, right? Because the reason why the winter time is going to slow down everything, right? So yeast are going to grow slower in winter time, right? So that's the reason why you think of, maybe shifting to or doing this stuff, the back and forth, right? But if you have two things, the risk of yeast, this coming, I will choose this one, right? Regardless of when we are feeding. The strategy that we are proposing here is only because of cost, and sometimes because this Elan C33 is a little more expensive than Elan 74. So it's a way to help customers to save some money. But if you have concerns, I will go all in with Elan C33 when the yeast it may be a problem.
Thanks, Nelson. We can flip back.
All right. And so here is the current trend, is moving towards more piles and bunkers, and it seems like the silos, the upright silos, are nothing but like photo props and stuff like that. I don't see a lot of people using them anymore here in the States, at least. All right, so here is a little bit of funny pictures. Like you can choose, when you are farming, right? You can choose between making silage or compost. And here are some horror pictures. Most of them are from Europe. See here, you see an example of rotting silage. Here you see an example of extensive mold growth. That's probably, lack of packing combined with, air exposure. Here you have simply heat damage. Same thing, lack of packing, a lot of air going in, and everything heat up to a browning point. Well done. And here you have the typical sign of Clostridial infection. That band of darker green in the pile. And here is another pile of, this doesn't qualify as silo. It's just compost covered with a piece of plastic, in my opinion. Anyways, I want to share with you that compaction is critical to the quality of the silage. Okay, so here are the reasons: because it reduces the amount of oxygen in the forage mass, right? And that, when you do that, you limit the growth of microorganisms that cause fermentation issues and spoilage, right? Now, when you are packing, also you are doing basically packing, right? You are putting more, you're putting more silage in that same footprint, right? So you don't need to go higher, because that's create a safety issue, right? So good packing will allow you to, put all that mass in the same footprint. And overall, the higher densities are going to reduce the annual cost of storage per ton of feed, and usually it's going to reduce your losses during storage. So here is the recommendation here, like the density recommendation that you want to achieve is around 15 pounds of dry matter per cubic foot. This is equivalent in metric, around 240 and 250 kilos of dry matter per cubic meter, right? Now, why is the recommendation? Because, here in this chart, you can see how much you expect in terms of dry matter loss after 180 days of storage, right? You can see that you can achieve more, you can keep pushing this stuff, pushing more pounds in that square foot, or that cubic foot, or more kilos in that cubic meter, but your increase is marginal. In terms of, dry matter loss. So it's a good compromise. The 15 is a good compromise. Allows you, it's achievable, and allows you, to limit your dry matter losses. Now, there is a pound increase, going from 14 to 15. It is equivalent to 1% dry matter recovery. Okay. So when you put those monies to work, let's say that we have an example here. You have a bunker. I'm sorry about this in feet. 150 to 75 by 12 feet high, right? You have around 2,700 tons of silage there. And if you were to go, from 14 pounds per cubic foot to 15, just push that extra pound in terms of, if you were to value, these are all numbers, the silage at $45, the the cost of that, if you apply the percents that I had in the other slide, you have a difference of $0.4 either lost or gained per ton. If you apply that to the 2,700 tons of silage, you have, $1,000 opportunity there, right? So packing is worth it, right? Doing it right is worth it. Now, what are the factors of good packing? Axle load, right? You want a lot of weight on that pile, and here is what happens. You can see this is a bulb, in of pressure. Higher, you double the weight. You're compacting deeper, right? Now, there is always a question: how much weight do I need? And this is an old rule of thumb, right? The 800 rule, that relates how much weight do you need in a pile related to how much tons are delivered per hour, right? So in this example, if a chopper is delivering to a pad like 100 tons, per hour, you multiply the 100 tons by the 800 of the rule, and then you have 80,000 pounds worth of pack tractors that you need, right? So in general, you need two heavy pack tractors and one push per each chopper that you have in the field, to keep up with the newer choppers. Okay. And you can see it from the other side too, the 2.5 rule. That is, if you have like it's how much can be delivered, right? Depending on how much weight do you have. If you have like a 40,000 pound pack tractor in your pile, and you multiply the tons, that equivalent tons for 2.5, we give you the 50 tons that can be delivered per hour to a pile, right? All right, so you have to control the delivery rate. In general, this is a study that it was made to determine, what is the optimal layer thickness. You see here in the x-axis, 10 centimeters, 15, and 20 centimeters. So you put different thickness layers, and then they apply the same packing weight, right? And then they measure here the density. What was it, how effective was that packing? And you can see that they were able to pack, 18.9 pounds of dry matter in 1 cubic feet when they were packing a layer of 4 inches or 10 centimeters. And as you go thicker and thicker, you are not able to pack as many pounds in the same volume. So here is where the recommendation is to have effective compaction. I mean, the key for effective compaction is to lay down like thin layers, remain between 4 and 6 inches, no more than that, because, you can keep pushing something, but it's not going to work. It's not going to compact. All right, here is the difference between having like a narrow tire and a wide high flotation tire, right? So you have the same weight that is distributed in a wider surface. So you have less compaction with these tires, the fat tires. That's what you want in the field. But when you are packing, you want narrow tires. And also, another thing that you have to keep an eye on is the tire inflation. When you are farming, when you are in the field, you want your tires flat, right? Because you don't want to create too much compaction in the soil. The opposite happens in the pile. you want compaction, so you have to higher, go higher in your tire pressure, right? Here is an example that you look at the maximum compaction, how many psi were measured at different depths when you change the pressure in your tires. So you have low pressure, flat tires. You can see that in the first 4 inches, you can measure 16 psi. As you keep going deeper, at 30 centimeters or 12 inches, you see, you can measure 15 psi. But if you keep going lower and lower, that affects, you don't measure many psi. You're not compacting much, right? On the opposite, when you go up in psi's, more pressure in your tires, you increase considerably, in the first 10 centimeters, how much psi you're exerting. But I want you to notice this. There is not much difference if you go deeper. So that tells you that when the recommendation of thin layers is important, like there is not much difference when you go to 12 inches here, regardless of how many psi you put in your tires, the same way, basically you get the same psi. The difference is here in the first 4 or 10 centimeters, right? So thin inches. If you remember anything from this presentation, is thin layers, please. 4 to 6. Now, in the field, when you're farming, 80% of the compaction is done in the first pass. That's why you keep, hitting the same roots, right? In the same roots in the field, when you are farming. 80% is done of the compaction is done in the first pass. But when you are packing a silo, it's not a good idea to follow the same path all the time. So the recommendation is that you go and overlap passes so you can, you are compacting the pile more effectively, right? Now the other thing is that people sometimes they get it wrong, like they did thick layers in the beginning and they think they are going to compensate by doing, like by overpacking the top. That's the worst thing that you can do, because all you do, we saw it before, like you don't, the psi, if you keep going low, you're just compacting the top layer. And the problem is that with each pass that you make, like for instance, this was in Russia, this cat packed the top of this bunker for 5 hours. It was nothing but a waste of time and fuel, because you're effective like what, like the 4 to 6 inches. And the problem is that this process, the only thing it does is to juice out all the mass, right? And then you're losing sugars, right? And the only thing that you do there is like to provide fuel for anaerobic spoilage organisms. So again, spread thin layers, 6 inches or less.
What about packing rollers, Nelson?
Packing rollers work, right? I have seen them working, but the recommendation is the same, right? Thin layers, not because the fact that you have a packing roller, right? It doesn't allow you, it doesn't change the recommendation that you can go thicker layers. It won't be effective. It is an example of large dairies, preparing the bunker for being filled. You can see that they cover the walls of the bunker with plastic. And here is an example of circulation in a pad. The worst thing that you can do is to have like the truck come and try to help, packing and, climbing on the pile and dumping the stuff there. That's the worst thing that you can do, because you're dragging a lot of dirt and you're inoculating your whole pile of silage with Clostridium. You're going to have a huge problem there, right? So you want to minimize the circulation of the trucks that are coming with dirty, tires in the path, right? So this is a good thing too. You just drop the stuff, go across, go away, right? The optimum will be like this, but it's not, it's not always possible, like to minimize the circulation of the tractors in the paved area. And usually what you want to do is to put the most experienced guy, you know, the better trained guy, you know, in the push tractor. You know, he's the guy that should call the shots, and he should set the pace of delivery, you know, not the trucks. Here is a strategy. You know, usually what you want to do is a progressive wedge. You know, the reason for this is that you are mixing, you know, the material as it comes, you know, from different fields. And here is an example of how to make a burrito, basically a bag out of a bunker. You see here the wall, and they put a drainage tile to protect the plastic so it doesn't get ripped on the rough surface of the concrete. After, what they do, they weigh the plastic here on top and in the bottom, and they put a drainage tile here to catch any effluent, right? To keep that effluent from infiltrating into a silo mass, right? And they move, you know, the plastic as they are they are filling. And at the end, what they do, they put an oxygen barrier on top, and then they flip and close with the plastic. And the idea of this tile also is to capture any runoff or snow melt that may later fall. Now the question is that, yeah, that sounds like a lot of plastic, right? And you sometimes hear that question: do I really have to spend that money on plastic? You know, cover or not to cover? And here is a study that they compare, you know, a sealed versus an unsealed silo, and you can see that dry matter loss is quite considerable, you know, when you don't seal your plastic, and that not only affects the dry matter loss, but also the digestibility, right? So you can see here that there was an extensive deterioration the first 25 centimeters of that pile, and you know, you had a 25% dry matter loss in the top 75, and a 75% dry matter loss here in the first, you know, 25 centimeters, right? The aerobic spoilage organism consume the nutrients, the digestibility drop, and the pH is super high. So here is party for the microorganisms. Now, what are the effects of feeding this crap? You know, like this is, you know, basically spoiled silage that was put into steers. These were cannulated steers, and they wanted to see what are the effects of feeding, you know, spoiled silage. You know, they used cannulated steers because they were not willing to eat this material, right? Now here is what they were doing. You know, they took the steers and they either feed them 0%, or they put in through the cannula, you know, 0%, 25, 50, up to 75% of this material, you know, spoiled forage in the ration. The dry matter digestibility, you can see how it declines, you know, dry matter digestibility from 74 all the way down to 65%, right? And then the NDF digestibility also declined, you know, from 63 to 53. And the intake also hurt, right? The animals were not willing to eat, from 18 down to 15. Now, if you think in terms of milk, a drop of NDF of that 7% here, you know, the 63 to a 56 is a 7% drop of NDF. That's equivalent of losing 2 kilos of milk. So these are the conclusions of that study. You know, as you increase the spoiled silage in the ration, there was a linear decline in intakes, the digestibility, and both the NDF and dry matter, both the digestibilities drop. And at the moment they did a ruminant equation, and you can see, they could see that the spoiled silage just disturbed completely the integrity of the rumen mat.
Now, just if I can just pause you for just a second, Nelson, one more time. We are getting close to 9 o'clock, so I do want to just give a heads up to anybody that does want questions, maybe you should be typing them in now, and that way we can make sure Nelson does get them. So just as kind of Nelson is getting towards the end, I do want anybody who's on the call, just if you do have any, kind of last minute questions, type them in now, and that way we can make sure we get them, get to them before we wrap up. Nelson, all yours again.
Perfect. Yes. So here are recommendations on how to fill. Usually you don't want to make silage piles on dirt, right? Ideally, you want at least a solid base. It can be concrete, asphalt, or sometimes you can do other things, but you don't want to do it in loose dirt, right? Make sure that you pay attention to the slopes. You don't want water to come in. You want water to go out. Any rain, ensure proper drainage of the area. The height of the pile should be determined by the equipment that you have for feet out. Like if you have a telehandler or you have a rake or something like that, that should be the limit for you to going in height with your pile, right? The location should be easy to load and unload. Ideally, the orientation there is recommended to have sun exposure to the open face to keep the area dry, when you are working. And for sure, again, you can see it here. They are starting with thin layers. The recommendation, again, solid base. The height should be set by the equipment that you're going to use when you are feeding out. And this is important. The recommendation of the slope should be 1 to 3. So that means 1 foot raise for 3 feet of horizontal run, right? If you keep going up, it's just going to make the situation more dangerous for the tractor drivers. And the other thing is that when you have this situation here, with a slope, it's clearly that looks more like a 1-to-1 ratio, not a 3-to-1 ratio. Nobody packs there, right? And that's going to become a pocket for microorganisms, and the stuff's going to start spoiling. The ideal way is like what you see here, like a pile that you can pack in every direction. And here you see how they're deploying the oxygen barrier film. The recommendation is to use this stuff in addition to the other plastic. And for sure, you don't want to see a situation where you have plastic, billowing and flying in the wind and leaving everything exposed. You want to put proper weights. What you see here in the States sometimes is those tires that are they make holes on the side, so you have the weight of the tire, but you don't have the water accumulation that's just going to breed insects and stuff like that, mosquitoes. This is another alternative that you have to weigh down the plastic, which is like gravel bags. And the nice thing is that once you are done using them, you can pile them nicely in a pallet, so you don't have like a big mess. These are the tires. What else? So here is a summary, and with this, I'm getting ready to finish here. Key management practice, select the right hybrid for your fields, right? Pay attention to the traits, pay attention to your fields, the disease pressure and all that matter. Harvest at the optimum stage of maturity, pay attention to the dry matter content. Use the correct size of bunker of pile. Do not overfill bunkers of piles. You want to send everybody home, safely every day. You don't want to create, danger situations. Employ well-trained, experienced people, especially those who operate the forage harvester, the pack tractor, and the bagging machine. You have to make sure they provide training as needed, right? Apply the appropriate bacterial inoculant. Achieve the uniform packing density in bunkers and piles. Try to strive for the 15 pounds dry matter per square foot, cubic foot, the 240 to 150 kilos per cubic meter. Make sure that you have an effective seal in the surface of the bunkers and piles. Consider using the double polyethylene sheets or the oxygen barrier film, right? Make sure that that protective seal remains throughout the silo period. Like inspect. That's one thing that you want to do. Inspect, regularly for holes. Look for holes. Sometimes you have animals climbing, ribs and stuff. Repair them. Prevent air from getting into your pile. The other thing is that once you are feeding out, follow proper phase management practice during the entire feed out period. And also, try to schedule regular meetings with your forage team. And that's all I had prepared for today. And, you have resources available. You have your forage team. You have your agents. You have this silage zone manual. We are in our 5th edition already. So if you want to have, this book, talk to your agent, talk to your pioneer rep. It's available. And the other thing is that universities, they do a great job with extension. And
yep, certainly.
that's it.
Yeah, certainly. Thanks, Nelson. And, certainly that was one of the comments I wanted to make sure we did make too, was just, talking to your pioneer rep, talk to your pioneer agronomist, because of the variability, because of, the challenges that have arrived for 2025 for a lot of growers. Just reach out, have those conversations, and, you get the whole network, that includes folks like Nelson, in behind that pioneer rep and, the pioneer agronomist. So don't be afraid to reach out to them. There's one last question, then we'll wrap up, Nelson, and it's just, Ben just wondered if you could comment a little bit on bagging silage. We talked a lot about bunks and packing. Any comments on bags of silage and how well they can work or not?
Yeah, bags work great. The problem that you have only, what it helps you is like you can segregate easily, one field from another field. So it helps you, to manage qualities, and you can mix and match, right? The issue you have with bags is the footprint, right? You need a lot of space, and sometimes it can be a little challenging during wintertime to feed, because of muddy conditions and stuff like that. But no, they do work, and they do work well.
All right, wonderful. Well, I'm just going to double check the Q&A boxes to make sure another one popped in. How much does it cost to grow 1 acre of corn? Do you have that number in your head, Nelson? That's a big question, Mark. I know that's putting you on the spot.
Yeah, no, that's a great question, and I do not have that in my head. My function goes more towards nutrition, so I'm not as much in tune with the agronomy side of the business.
No, and that's fair enough. And I think that's probably one, to touch base with your rep on as well, because obviously it's gonna impact quite a bit depending on fertilizer and fungicides and if you're renting versus not and all those types of things. So it's probably a pretty wide ranging number, but one that certainly, talking to folks around your neighborhood, you can probably get a pretty good idea in terms of what the cost is in that area. So, so with that, Nelson, thanks very much for coming on this morning with us. We really appreciate all of your insight. Right from that idea I certainly took away that I'm not going to trust my eye. I'm going to put it through a chopper, and then I'm going to put it through and get an actual dry matter analysis on it just to see what it is, so that I'm not just going based on my eye. And then that packing, keeping it down to 4 to 6 inches. Just thin layers all the time, and the graphics you had in terms of tire and compaction certainly was helpful in that. So and everything else that went along with it, I certainly gained a whole bunch. I hope that everybody on the call did as well. Thanks for joining us, and make sure that if you do have questions, just reach out to your local Pioneer rep. Thanks, everybody.
Thank you. See you guys.